My name is Samuelson. This is me. Engineering from Lautech. I'm going to be talking about not just try. Sure. How many of us are self-taught developers? Self-taught, you didn't really attend a class. Oh, good. A number of us are. Okay. How many of us have a different programming language that we use apart from Python? PHP, Java, okay? A good number of us. So, I also started as a self-taught developer. Well, I still am a self-taught developer because I just picked up Python a couple months back again. My first work with Python was in 2015. I needed to scrape some data from my mom's phone, use the data to create an SMS list. She wanted to send out Happy Christmas message everyone on our phone contact. So she gave me the pen, the book, to write it down, every number, every name. I'm going to send the message. Wow. So, and I'd learned that you can use Python first. I'd come across Python for security. And I was very much interested in security, pen testing, digital forensics, and all of that. I've not started that yet till date, but I'm good. So what I did then was, okay, you know what, mommy, give me some time, 15 or 30 minutes. I exported all our contacts to a vCard. I looked through the vCard, I saw the format, how it was put in place, the numbers, what I needed to do with the numbers, and then some formatting. If it's 070, you have to format 470, etc. So I wrote up a script that was able to do that. 30 minutes. But the good thing is, though that took 30 minutes, I don't know how long it would have taken me to write it all out by hand. But then, every other time I could always reuse the same script for the same purpose. But then I thought of, why can't I make this a bit better? I could give this out. There are many people who use bulk SMS solutions. I could create a little SMS solution for people to use. So I thought about going back to the script I wrote earlier. Of course, I don't need to tell you that it was not couldn't work because it was made to work for just that purpose. But really, it should be something extensible. I should be able to reuse it, add a few more functionalities to it. But then, it was my first complicated script I had come up with back then. But today, in my work with software, it's been some time now. I want to look at who I am, electronic and electrical engineering. Lautech. But very quickly, I want us to go. So very fast, she asked the question the other time, what is try? Try is an acronym for don't repeat yourself. Simple, that's all it is. Just don't repeat yourself. It is a principle of software development. And I wrote it there. Not a convention or a paradigm per se. It is a principle. Gravity is a principle. Physics. It's a law. It's something that you shouldn't break. If you break it, you're going to get a lot of bad results coming out from that. So to differentiate is very good from a convention. A convention in Python is like something. Okay, in Python, do we use single quotes or double quotes or normal strings? Anyone, yes, you can use anyone. But I can decide that, okay, in all this software code I'm going to write, I'm going to be using single quotes for my strings. I'm going to escape single quotes if they occur in a string I'm trying to create, and it's going to be easy for me to just put in double quotes. in that string. Because I'm using single quotes, I don't have to escape double quotes. Now that's a convention that I've come up with. Although there are much more general conventions that exist. For example, okay, there's the Zen of Python that lays out some rules. There are things that we should follow. Your code won't break if you don't follow it. You'll still be able to write usable functioning code if you don't. But they are advised to do it. We are advised, rather, software developers to do that. But dry data is not just a convention or just a paradigm. It is a principle of software development. I know, just like probably like I did, when I was starting out learning Python, went onto the Python documentation, started reading through, okay, what can I do with it? Probably found some examples, hello world example, creating a storyboard from user input, collect some user input, and then you concatenate it with a few template strings, come up with a storyline. For example, what is your name? Samuelson. How old are you? I'm 23. What do you do for a living? Oh, I eat. And then you say, you create a string as an output. I am Samuelson, I do this, and this is what I do for a living. Something very simple. But no one ever really, probably we didn't get advice, but it's not something that we know. That before you learn how to use a programming language, you should learn first of all, number one, why do you want to program? And two, how do you program? We learn how to use a programming language because we didn't learn how to think like a programmer. Because if you learn how to think like a programmer, then you will be forced to obey the principle, the try principle. So it says that every piece of knowledge must have a single, unambiguous, authoritative representation within a system. Now, the keywords there are single, unambiguous, and authoritative representation. If you're not going to repeat yourself in code, then every piece of knowledge, every statement of fact in your code base, in your entire code base, has to have just a single, unambiguous, authoritative representation. Now, what is meant by piece of knowledge? Piece of knowledge would be, if you have ever worked with, say, a web framework or anything, or if you know PHP, for example, you'd know you have to create database connection objects. So, in your code, you shouldn't, every file that has to access the database should not be creating a database connection object. If you are going to be scraping a website, every file that you're working with that needs to have a scraper object that you created should not have to repeatedly say, okay, I'm going to declare and instantiate this every single time I need to do that. Rather, you have a single file, call it a variables folder, which houses all your variables, really. But they are not variables in the sense that they are more or less predetermined. So if you call it, make them constant, that will not change. So they have a single point that is unambiguous, very clear. This is what I'm declaring, and this is the value I'm giving to it. So if you are going to need a different username, if I'm going to need a different username for a database connection request, it is there that it will be changed. Not that, okay, you have 15 files accessing the database. Every time you need to change the database user, you have to go into the 15 files to change the username and the password. Now that's going to be too much work. So dry state, every piece of knowledge, everything that you're declaring, anything you're going to be used, anything that is not a programming, it's not a programming language keyword, it's not a reserved word, if it's an identifier, then it has to have a single, unambiguous, authoritative representation within a system that every other part of your software code that needs to use it can always reference. Are we with me up to there, please? So, but the thing is, writing dry code will help us to write high quality code in hopes, because really that's the aim of writing any software that we use. So very quickly, I would like to give a definition of software quality from Wikipedia. Software quality is actually split into the functional quality and the structural quality. This software functional quality is something that we all are acquainted with. It is a measure of how well your software complies with or conforms to a given design based on your functional requirements. For example, you need a simple calculator. The function of the calculator software is to calculate stuff. Probably one of the functions is that it should be able to take two numbers, add them together, and give us the answer based on whatever rule you have set apart for your addition. Now, high quality software in that regard should be able to take those two numbers, add them together, and give us the proper result, right? But the other part of software quality that we are not so conversant with is what is referred to as software structural quality. Software structural quality refers to how much your software meets non-functional requirements. Non-functional requirements of situations such as fitness for purpose of a piece of software, how it compares to competitors in the marketplace and what product that may be your functional requirement, but rather it is the degree to which correct it is not the degree to which correct software is produced, but that is functional quality. Functional quality is the degree to which your software is correct, it meets the functional requirement. But structural quality refers to how much it is robust, how much it is scalable, how much it is maintainable, really how much it is reusable. And the truth is that we all are functional quality software producers. We know how to produce software that meets our functional requirements. But the thing is, writing high quality software that is in the functional sense, but with the same software not being high quality in the structural sense will affect a lot of things. For example, you have this code, a simple game. All it does is just iterate a few blocks. That's say 1 million people have to play on the internet. All it does is this. Instantiate name equals item, have wrong. You put sample to show you. But this go with my name, I think we all develop an end. So you have the name equals input, tell me your name. You get the user's name and then you create a symbol and if else. But every time you call your if else statement, you are declaring what the computer should give as output, and you are repeating it in the if statement and the else statement. The only thing that is different is the parameter. Okay, if the person puts the number wrong, the person puts the number right. But you are repeating every other thing. If 1 million people are going to play the game at the same time, you think it should be no problem, just that it was. Read it, because you don't know 10 people are playing, 10 people are playing. When you are talking about scalability, you are going up to say 10,000 users, 100,000 users at a time. So I created a little function. What it does is calculate prime numbers. Now it calculates prime numbers from 1 to 1,000 within about less than a second, about 500 milliseconds. Then I created another one, the same prime numbers using the algorithm and the try number to uses spent several nanoseconds. Very simple. Like I have 1,000 users using the first thing at the same time. That means each user will have the real latency of about 1,000 of about 500 seconds compared to the other one which will have the latency of say of 5 microseconds or 5 milliseconds, which is way better compared when we're comparing the performance. So one of the usefulness of writers helps you write better performance code. And very quickly, I'll talk about reusable code in terms of all the concepts. Now, the object-oriented programming is an approach to programming is focused on representation of real-life data and real-life objects and their data using code. Normally, as programmers, we are taught to think of the logical process, how this function is going to be done. But with object-oriented programming, we are forced to focus on the data and the object rather than the logic that data and the objects will be manipulated. But for us to write reusable code, we need to focus on two things. OOP introduces actually many things that needs to be. For reusable code, we need to focus on abstraction and encapsulation. Abstraction is a way of limiting the scope of the problem you're talking about. But encapsulation talks about how you declare the interface by which people who want to use the code actually interact with your software. And focusing a bit more on abstraction. Abstraction is the way we represent the object. If you have any problem, the first thing to do is not to bring out your computer and start coding away. The first thing you want to do is to understand the problem. When you understand the problem, you will see every problem in the world that you have to solve. Especially when we're talking about real life issues. Every problem in the world that you have to solve have a beating component. And so if you start pulling out straight without understanding the whole scope of the problem yet, you will see that you are creating solutions that are repeating. It may not be a whole block that will repeat, just a part of the block repeating itself in another part. But when you understand how to properly, when you understand the whole scope of the problem, you'll be able to map out portions of the problem that repeat. And so you know that the solution will be just map it out as a single solution that's using across domains that you have identified. And the other thing is this. With abstractions, it answers this, what do I need to represent my object? Abstraction is the way, is how you break down an object. Say, for example, if I represent a customer, the only two things that you need about the customer is the customer name and the customer code. And then you want to know how much the customer pays you whenever they come to buy things. The other things about the customer that you don't care to know that. You don't care to know the customer's ID. You don't care to know the customer's weight. You don't care to know about a lot of things about the customer at that point. The only three things. So abstraction says take away all the things about the object that we do not need at this point to solve problems. I'm really focusing for you. And then encapsulation talks about hiding complexity, providing an interface, and bundling data with the object. Now, whenever we write object-oriented code, it is something easy for us to just define your class, define your methods, and your self-methods. In the methods, you can declare as many methods you want. You can declare your hidden and the but when you need to write reusable code, the first thing you need to do is that after you have abstracted away all things that you don't need, then you focus on how you implement your interface. Now, for your customer data, you'd probably want to first validate the customer name, right? You validate the customer code when you're receiving data about a particular customer, and then you want to return if the customer is a valid customer or not. Now, the best thing to do will not be to, write and expose customer.name valid, customer.code valid, and customer.validity. And then you allow anybody who wants to use your customer class to call those three methods in sequence. And so when those three methods are actually true, then you can say, yeah, your customer is a valid customer. Rather, if you're going to be writing reusable code, it's easier for you to just encapsulate, cover up functions that other developers using your code do not need to know. So how you do that is simple. You just look at it. What am I trying to achieve with this customer class? Really, all I need to know is that I need to know that the customer is valid. So anybody calling the class will just want to say, I want to set my customer's name, customer's code, and I want to check if the person is valid. Then simple, write a validation method that will check in the background if the name is valid, if the customer code is valid, if every other thing about the customer you need to know is valid. And then whoever is using the class can just call the customer.isValid, and then you have either true or false. Very simple. You encapsulate things that you don't know. You don't need others to know. You hide away the complexity of your implementation. It answers how and hides how your code is implemented and presents a unified interface for interaction and manipulation of objects. So putting it all together, the first thing you need to do is understand the problem to be solved, identify objects to be created, and create your objects abstractions. Your object abstractions are the things you need to know about your objects. What are the other things, what are the things rather that you need to know? You don't focus on customer high color when all you need to know about the customer is the customer name and the customer code. Then after that, you implement your object methods. You implement your object methods, what are the actions you need to be able to perform on your objects? Once you have that down, the next thing is to selectively expose object methods. That is where you encapsulate. You cover up the aspects of your implementation that others do not necessarily need to know about. And then the last thing is you look at this. You write code with simplicity greater than consistency and greater than completeness. Now, simplicity means code that you write is very easy to read. Easy to read, easy to understand. A developer comes to take a look at your code, probably wants to reuse it. Maybe the person is a new developer working for the company you originally wrote the code for, and they want to maintain it, they want to add some more functionalities into it. They should be able to read your code and understand exactly what you are doing. They may not understand at the point why you are doing it, but the first thing they should be able to look at your code is, oh, okay, this line tries to do this. So the next thing is consistency. The way you expose your APIs, your methods in your classes, they should be consistent. Shouldn't, for example, one is your naming should be consistent. If you use camel case, by all means use camel case for your properties. If you use title case for your properties, be consistent with the use of that, so that when a developer that wants to extend or reuse your code is in doubt, once he can see, okay, this method actually goes with this convention, he can recognize it, whether it's an hidden method or it's a method he should be able to call from outside. And the last thing is this, completeness. Many times as developers, we tend to overemphasize code completeness. The truth is, no software project is ever completed. At least nothing that is going to be very scalable. Google is not completed. Google is being developed every day. Facebook is not completed. Else they won't need thousands of developers that they have. It is always an ongoing work. The first thing you need to do is identify what's the pain point. What is the most important thing you want your code to achieve? Once you achieve that, then you can release that and then ship incremental updates to your users. So the most important thing is your code must be, first of all, simple. And after it's simple, then you must ensure that you are consistent with your encapsulation, the way you expose your data interfaces, your object interfaces, rather. And in the end, completeness only comes last, after you have been able to ensure your code is simple and consistent. There are other methods, there are other things about software quality that I've not been able to mention, including reliability and other things. But I'm sure if we focus on this, simplicity, consistency, and completeness, we will be able to write code that is not just functionally of high quality, but also structurally of high quality. So you find out that it's not just the fact that you have to write dry code that should not repeat yourself. It goes beyond not just repeating yourself. It goes far more into understanding the problem to be solved and being able to come up with, one, a good abstraction for that problem, and two, being able to properly encapsulate your complexities, and you expose selected methods, things that other developers need to know. Things they don't need to know, you hide from them. I believe if we do this, we'll be able to write software projects with long lives, because one of the banes of writing poor quality code is that it won't live long. People who need to extend it will not be able to. When Linux came out, it was free and open source for everybody. There was Windows at the same point. But Linux is gaining traction and has lived up till this point, not because it was better than Windows when it was released, but because it made it easy for those who needed to improve it to get into the code. It was easy for them to understand, and they were able to extend it. So when your code is simple and consistent, completeness will always come. We want code to be complete, we want it to be complete. Yes, it will come, because others who need to extend it, who need to reuse your code, who need to maintain it, who need to write. For example, Paystack, you can build other things on Paystack, which is probably itself built on, I think, Flutterwave's money engine. So when your code is reusable, it is easy for it to become more complete, because then it becomes easy for others who need to use your code to build better things upon your initial foundation. So thank you all for listening. I hope I've been able to explain these things better.